intro. Thank you for inviting me here. Can I start? Yeah. Right, yeah. I'm going to talk today about the moral-machine experiment and a couple of follow-up experiments and follow-up work with this amazing collaborators. And we'll start first with the moral-machine project, which is about automated vehicles, driverless cars, which are, as you all know, already being tested on the roads, and they probably will become reality sometime soon, and which is probably something good. Many experts predict or calculate that these cars will actually remove 90% of the current car crashes. Now, for the remaining 10%, some of these might involve the car resolving moral trade-offs. And a very stylized, abstracted version of this moral trade-off could be illustrated by a version that is inspired by the trolley problem. In this version, you have the driverless car headed on the street, and 10 pedestrians jump in front of it. Brake fail, the car is going to kill those 10 pedestrians. There's only one way out, which is that the car will swerve into a passerby and sacrifice them. In another version, the car would swerve into a barrier and sacrifice its own passengers. And should the car sacrifice its own passenger to save 10 pedestrians? Now, in a study that was published in 2016 by my advisor and his collaborators, Awad and Awad, they found out that most people actually approve of this choice, where they said that yes, the car should sacrifice its own passenger in order to save more lives. But there was a catch. When they were asked if they're willing to buy such driverless cars, they all said that they would not be happy to do so, even though that they thought everyone else should do that. Now, of course, when we talk about these kind of scenarios, they are kind of very rare. They probably never happen, or probably things that we never encountered in our lives, which is true. But while we don't encounter such trolley types dilemmas in our lives, we actually do face and resolve moral trade-offs in our daily life. One example is when you go to buy a car, a regular car. You are faced with the choice of buying an SUV, or you could buy a regular car, and an SUV will give you probably more protection, but that at the cost of everyone else. So that is kind of a moral trade-off that you make. When you're driving on the road, for example, there are some kind of things that you would do while driving, and one of them is like the lateral aligning within your own lane, which is, as long as you are within your own lane, you could do whatever you want. And let's say now you have like a big truck on your right, you have a cyclist on your left, then the way you align yourself could actually shift risk between the different road users. So for example, you could go closer to the cyclist, which means more risk to the cyclist. You could go closer to the truck, which means more risk to you. And that's just you driving yourself. Now let's say instead of just people are driving, let's say we have a driverless car which you have that is being driven by one kind of software that is going to be doing these things and making these decisions based on some other factors. Let's say now in this kind of, we talked about this one instance, but let's say now after 1 million of those let's say instances where the car is doing the same thing over and over, let's say you have software A that will always go closer to the truck, and in this case you might end up, as a result, you might end up with 5 passenger fatalities in aggregate, while you have another software that basically drives closer to the cyclist, and let's say after a long time you realize that this resulted or materialized in 1 cyclist fatalities. Now, this is kind of in aggregate, you're kind of like making a choice between killing 5 passengers versus 1 cyclist. So in a way, while we're talking about, this discussion is more about how the risk will be distributed in terms of the actual scenarios, but in aggregate is going to be materialized into actual lives being traded. And the issue is that current driverless technologies are actually making these decisions based on other things, right? Like they want to maximize the, probably like make the trip faster or more convenient, or maybe they want to minimize the liability on the company. And in fact, this kind of way of making those decisions, Google has a patent about calculations of risks and from the probability and the risk magnitude. So here we're trying to say, let's try to pay attention on how these decisions are being made and who's actually being systematically disadvantaged by these decisions among the road users. Now this is a very tough question, of course, and while we think that experts should be taking care of it, we still also think that the public has something to say, especially with the emotional salience of crashes that are happening by driverless cars. So this is why we decided to build the moral machine, which is a website that generates random moral dilemmas that are faced by a driverless car and asks you what you think the car should do in those dilemmas. And this is one example. It's very similar to what I just described before. You have a driverless car headed on the street, and then 4 pedestrians jump in front of it. And as in every story, the brake fails and the car is going to kill them. The only way out, if it swerves into a barrier, but this means the car will sacrifice its one passenger. Sorry. What did I do? So what should the car do? And then the user would click and choose which of these 2 things to do. And then after 13 scenarios of this, the user will show them like summary of the results, just to make it like something that they will find like worth doing this exercise, tell them how they answered and how their answers compare to other people. And this kind of website was basically a randomized control experiment that was also meant to test the different factors. So to increase also the external validity, we considered a variety of characters that we had, like males and females, elderly, young, doctors, athletes, dog and cat. And basically the kind of scene that we created is composed of 4 components. One of them, whether the car should stay or swerve, it's kind of omission versus commission, which is a factor that is usually relevant in moral psychology and in philosophy. The other factor is whether the casualties, the potential casualties are pedestrians or passengers, and how relationship to the car. And if they are pedestrians, whether they are crossing legally or illegally, and then what are the type of those characters, like any characteristics of those characters. Like in this example, we have elderly versus young. But in total, we had 9 attributes. So we had this interventionism that I talked about, the relation to AV, the legality, and then we also have these characteristics. We have the gender, age, fitness, social status, and humans versus pets, and the number of lives. And we also translated this website into 9 other languages, translation, forward translation, backward translation, painful task. And we had 4 million people coming to the website. They contributed to 40 million of these dilemmas that I just showed you. And we also had a survey at the end, which people could fill optionally. We had also like 500,000 people filling this survey. These data were collected within 18 months of the website's deployment. And we had people coming from different places in the world. You can see that there is like a lot of, some areas they have like a lot of people coming from. Just for comparison with the map of the lit world, places where there's like a light or electricity, you can see that there is a good coverage of places where they could have internet access or at least electricity. So what did we find? First of all, just to explain what we found, this is just to say, this is the x-axis is the difference in probability of saving. So here the probability of saving the ones on the right, which is humans, minus the probability of sparing the pets. So out of all the scenarios where we had humans, we kind of how often people saved them, and we subtract from that the pets answer. And in this case, it's like something around close to 0.6. Next, you could see also that in terms of number of lives, this number 1 here says that if you add 1 more life, this is how much people probability of sparing them increases. 2, 3, 4, and then you have the average for all. And then you could do the same thing for all the other 7 attributes. And you could also compare those 9 attributes together to see which ones people found much more, they were like much more in approval of. And down the list, you would see at the bottom line, there's these 3 attributes that people seem to agree with the most. The first one is sparing humans over pets. The second one is sparing more lives over fewer lives. And the third one is sparing younger lives over older lives. Now, this last one was quite an interesting point, which I'm going to get back to later. But even for this one, it's not completely driven by some specific types of characters. In fact, we could do the same thing for each character. So here as well, we could do that with baby stroller, and we see how often people spared that baby stroller. And then we compare that, we subtract from that how often people spared the adult male and female. And here we can see that they spared the baby almost like less than 0.2, much more. But then when we do that for all the characters, we could actually also compare them, and we could see which characters were spared the most by people. And at the top 4, you can see that all those characters are kind of younger kind of characters, or like include characters that are young. While at the bottom, aside from the dog and the cat and the criminal in between, you could see also the elderly man and woman came also at the bottom. So it seems like people find it quite acceptable to spare younger lives over older lives. The second thing is that because we had people coming from different places in different countries, we had actually people from almost every country and territory. But for this analysis that I'm going to talk about now, we only took countries that we had at least 200 people from. And we can calculate the same 9 numbers that I just showed you for every country now. We can also use that to calculate distance between every pair of countries, and then you could do some hierarchical clustering to basically generate a full dendrogram of all countries, and which kind of shows you how close 2 countries are to each other, or what is the closest country to each country. And from this dendrogram, we could also see 3 big clusters. But before getting into the clusters, I just want to say that here we're using, to color the names of the countries, we're using something that anthropologists kind of have accepted, which is this kind of a classification of countries, anthropological classification of countries called Engelhardt-Wilzel cultural map, which classified countries into 10 different classes. They do seem weird, usually, like some classes are like a South Asia, or Protestant, or Orthodox, Latin America, English-speaking, Confucian. And this is like for visual inspection. You could see how the similar colors are kind of like there's some kind of like a visual validation. We do also kind of statistical validation for this. But broadly speaking, we could find that countries cluster into 3 big clusters. One of them, which we call Western, it has many Western countries. You could see here Protestant countries, Catholic, and Orthodox, English-speaking countries as well. The second cluster has many Eastern countries. You would see here the South Asian and Confucian and Islamic countries. And then the third cluster, it's kind of like has 2 subclusters. One of them that has mainly Latin American countries, and the other one has like a former French colonies, which is kind of something that's kind of weird. And then you could see also what are the preferences of each cluster specifically. Now, just to look at this radio plot here, these are standardized numbers, so z equals 0 means the average. A note here is that in terms of the direction of those preferences that I mentioned, the direction, there is a kind of a universality in terms of this direction. For example, when it comes of the age dimension, sparing the younger over the elderly is quite something that is approved almost everywhere, but with different magnitude. So one thing you could see here, for example, that Eastern countries, the factor of sparing the young, people do spare the young over the elderly, but the magnitude of the difference is not as big as in the other countries. So it's something like where like Eastern cultures have a probably higher respect for the elderly, or the higher kind of concerns about the elderly. So we could do this. We could see what each of these three clusters, how they differ from each other in terms of their preferences. Another thing that we could also do is try to see what kind of anthropological or cross-country kind of, these are some factors that were collected by other anthropologists or ethnographers. One of them is called individualism. That is kind of one of the factors that is quite understood to be explaining differences between countries. So some countries or some societies are individualist, where people care about the individuals, they have higher trust in their institutions, while collectivists have a stronger family ties. People don't trust institutions, they seek their extended families for protection. And we see here that in individualist societies, people have they're more like an egalitarian, where like everybody should be treated equally. So sparing more lives become, or like being utilitarian is something that is more approved of. Another example is the rule of law, which is how strong the rule of law in a country, or how much law is respected in a country. It's correlated with people's wanting to spare the lawful. Now I want to talk a little bit about what these results that we found mean. First of all, I want to say that this exercise is basically, we're collecting what people think we should do, or what people think the things should do. It doesn't mean that this is what we will do, or this is what we are recommending that the manufacturers do. In the study of ethics, there is distinction between normative ethics and descriptive ethics, and this work is under the descriptive ethics. Now, descriptive ethics is usually useful to inform normative ethics, but it never dictated or it says anything about it. Or it's just like decide what it should do. So when it comes to normative ethics with respect to autonomous vehicles, we have one example, which is Germany, which was the first country that actually decided to draft normative rules for autonomous vehicles. They put this committee of experts, which span people in different expertise in law and ethics, engineering, and they have also a bishop. And this committee or commission, they put some kind of rules or guidelines, and most of these kind of guidelines were quite general and abstract as well. But it's useful to look at it and compare with what we find from the public. So one thing we found is that the strongest thing people approve of is that human over pets, and this is in quite like an agreement with those experts who said that we could accept damage to animals if that means sparing human lives. The second thing is more lives over fewer lives. It's not in complete disagreement. There is some kind of a statement that said you could reduce the number of injured persons. It's something that is justifiable, though the report also included other statements which said you should not be trading human lives as well, which kind of like somewhat contradict this one, but at least they don't completely disagree with this. They're not completely against this idea of more lives over fewer. The third thing which we also find, which is like the young over the elderly, which I talked about before, and this is now in clear disagreement with what those experts said, who said like you should not be any distinction based on any personal feature, and that includes age. And then lawful over unlawful, the committee has some kind of like a not completely clear sentence about this, but they had something say that if we can accept, if we understand this as people who are jaywalking has somewhat caused these dilemmas in the first place, then people who are crossing legally should not be punished for this. Now, the rules doesn't say that people who are jaywalking should accept more risk, but they kind of say that the others should not. And then higher status over lower status, obviously it's against the rules. So this is one thing, is the experts could basically see this input by the public. They may decide that some aspect of it, they might actually convince them to change. They might say, well, maybe there's something about children that people find very acceptable, so maybe we will make considerations for that. In fact, in other aspects, in health, for example, it is accepted to give priority for children. In other things, for example, like the status thing, the experts could just completely ignore this or completely say this is unacceptable, we're not going to take it into consideration. The second thing is when we talked about the different countries have different judgments or they have variations in terms of their judgments. I want to just talk about one example. Let's say now we have a car company and they have, let's say, some level of safety that they have. And now let's say this company figured out an update that they could do that would make their software safer, right? So basically they have some kind of a moral obligation to implement this safer software. But let's suppose now that this software is only safer if everybody is crossing legally. In fact, it's going to be a little bit riskier on those who are jaywalking. Then in that case, if this update is implemented, that means less harm for those who are legally crossing, but more harm for those who are illegally crossing. And should the company in this case implement this update or not? And what we see is that there might be some differences between, for example, countries where rule of law is strong, they might find this more acceptable than countries where rule of law is not as strong. So that's about the moral machine, the main kind of results. We also have used this data as well in two other projects. One of them in building kind of computational tools, which basically help kind of making moral decisions, after learning it from people. So the idea here is that you have people have latent evaluations of these values, and they use that into judging some scenarios. And then using kind of hierarchical Bayesian model, you could basically encode those factors into vectors, and then in order to know what the weights of those factors, you would basically use people's answer to reverse engineer those weights. And then this will, once you learn those weights, now you can predict what this person would answer in a new dilemma. Another work, which is with people from CMU, where here we assume that if people answer just only a handful of dilemmas, then we could actually kind of recover what they would have answered on all possible dilemmas, and then we build some kind of a collective decision maker that will basically could also have answers for new dilemmas. Now, of course, both of these are proof of concepts. We don't recommend that this is what should be done. Another work that we also have been working on. Now this is shifting something completely outside the moral machine kind of data. And now we're not talking about, first of all, we're not talking about dilemmas anymore now here in this work. We're talking about crashes. We're talking about cases where the driverless cars could avoid the crash, but it did not. But we also talk about shared control. So we're not talking about fully autonomous vehicles now. We're talking about cases like these ones, like the Tesla autopilot, for example, where you have both human and machines are involved in the driving, or Guardian, which is a model by Toyota, where the human is driving, but the car has a software that could intervene if it finds it necessary. And this is kind of relevant to, for example, the crash that happened in Arizona almost a year ago.
Goes to that. So I think that we should discuss either when to hear them or by okay.
Yeah, sorry about that. I think you
Should we continue?
I'm available, but I don't know.
Oh. Okay. So in this crash, how much time do I have? 5 more minutes. Okay. And in this crash here, what happened is there was a pedestrian who was killed, and in that case the car didn't see the pedestrians until it was too late, and the person in the car as well didn't see them. So kind of both the person and the car failed to do anything to avoid killing the pedestrian. And in a previous crash as well, which was the Tesla, which was like even 1 or 2 years before, the passenger died out of the crash because also the car could not identify white truck, and the passenger inside the car also couldn't see it. It's kind of showing like how they both failed to see it, and they both failed to do anything to avoid that. Now there was a lot of media coverage about this, and a lot of like a blame to these companies and the cars. But there was some kind of like an interesting anecdotes about cases where there's some kind of a rumor that came out saying that the person in the car was actually watching Harry Potter. So it's kind of, they were kind of like a reckless. And I think this came like over some kind of that the person in the truck said that they heard the theme song of Harry Potter. So there were articles saying this, and there was other articles who were saying that there's no basis for this for these kind of claims. And then in the recent crash as well, there were some kind of also articles saying that the person in the car was watching something on Hulu, so they were not really paying attention. And here was kind of interesting that there is some kind of a blame for the human in the car, and wanted to know if this is something more than just an anecdote. So we kind of used some kind of scenarios where now the car is on the street, and there is, for example, one person in front of the car, and the car could see, or like the person or the main driver could see that they could avoid that, but they don't do anything. And then the secondary driver that is supposed to override also doesn't do anything. And now, so you have this kind of a mistake of omission mistake by both drivers, which results in the death of the person. We also, in some version, we try to make, like, for ecological validity, we can make them look like a news piece where people are reading about it in the news, because what we care about is also to know what's people's reaction when they read about it in the news, not how will people react when they're driving. And we use these two models, but we also use two fictitious models where you have two humans driving, one in control and one secondary, and also two softwares, one in control and one secondary. And what we actually found, kind of systematically, that people in when the human is in control and machine is overriding, then people blame the human more when something wrong happens. But even in the opposite case, people also blame the human more. So it's kind of, no matter what the role of the human or the machine in this driving, if they both make mistake, then human is blamed more. Also, when we compare to the other fictitious models, we found that the blame to the machine is lower when it's driving with a human than when it's driving with another machine. So it seems like the blame to the machine just drops down, which is not the case for the human, where they are blamed almost equally if they're driving with another machine or driving with another human. Now I have other things, but I think I could skip those and then just talk about one last slide. And okay. It's about the universalities in the answers to the trolley problem. I'm not going to get into it because I need to give some background a little bit. I also wanted to say that we also had this project which was also inspired by the moral machine. It's called My Goodness. It's about effective altruism and how people give to charity and what factors could sway people from giving effectively. So in this case, for example, you have $100 that you want to give. You could give it to charity A, which would help 20 women in Africa by providing them with nutritious meals, or you could give it to charity B, which is going to help 4 women in the US. And then here's the kind of the considerations could be that you're helping more people, which is kind of the effective aspect, but you could also be like that you want to help people from your own country. If you're from US, for example, you want to help people from the US, or if there are some factors like maybe if you give a name to the victims, then it becomes more like an identifiable victim, which kind of like from psychology, from previous study, that this could be a factor that makes people sway people from giving effectively. And that's pretty much it. Yeah, thank you.